Hello, welcome back. Today we're going to look at Unit 7, Lesson 2, Forces and Motion. So lesson review, page 431. So the first one, gravity is a force that attracts all matter to each other. We can find this definition on page 424. Number 2, when the only force affecting an object is gravity, the object is in free fall. Number 3, the object traveling around another object in space is in orbit. So key concepts. Number 4, relate. The gravitational attraction between two objects will increase if one object acquires more mass. So on page 426, we see that gravity depends on mass. So the gravitational force between two objects increases with the mass of each object. So number 5, the gravitational attraction between two objects will decrease if the objects move farther apart. This can also be found on page 426. So we see here in this diagram that the two spheres farther apart, the gravitational attraction decreases. Also up here, the gravitational force between two objects increases as the distance between their centers decreases. So therefore, farther apart, the weaker it would be. Number 6, why are large astronomical bodies such as planets and stars round? So on page 425, we see here that the gravitational pull pulls the matter to its center. Some objects, like this here, this small moon, there is not enough mass to pull it into a sphere. Number 7, what two motions combine to produce an orbit? So, a forward and a downward motion. This can be found on 428. So here, the combination of forward motion and downward motion due to gravity combine to cause orbiting. Number 8, explain the difference between mass and weight. So mass is a measure of how much matter an object has. Weight is the force of gravity acting on that mass. Looks like I need to add another S there. So if we flip back here and we look here, we see that weight is a force that depends on mass. The greater the mass results in greater the weight. Number 9, critical thinking. The weight of an object on a planet depends not only on its mass, but also on the distance from the planet's center. This table lists the weight of 80 kilograms on each planet in the solar system. Uranus has more than 14 times as much mass as Earth, yet the gravitational force is less. Explain how this could be. Well, Uranus has a much larger radius than Earth. The distance to the center of Uranus is greater, so the gravitational attraction is less. 426 is where we could find this, and here it gives a couple different examples. It also talks here about the distances. Number 10. Why don't satellites in orbit fall to the ground? Why don't they fly off into space? Well, they do not fall because they move forward so fast that the planet curves away beneath them, putting more distance between the satellite and the ground. This increases the distance they have to fall. Now, they do not fly off into space because gravity keeps them falling towards Earth. So, 428 and 429 kind of explains this. All right, so here, a spacecraft in orbit is always falling but never hits the ground. This happens because of forward motion. It moves forward far enough the planet curves away under it. So it's exactly that much farther to fall. So it never actually gets closer to Earth. So the second part, why doesn't it fly off into space? So here, gravity provides a force that keeps objects in orbit. The force pulls one object into a path that curves around another object. Gravitational force is directed inward. For example, this inward force pulls the moon towards Earth and constantly changes the moon's motion. Interesting enough, here, when we talk about the speed that a satellite travels, to put that in perspective, it says 8 kilometers per second. So a projectile or a bullet coming out of a .22 long rifle travels at about 0.5 kilometers per second. So a satellite traveling at 8 kilometers per second is traveling significantly faster than a bullet. Anyway, hey, thank you and have a nice day.